Hello everyone, my name is Disha.
I am Padmash.
Our topic is inverting amplifiers. What is inverting amplifier? An inverting amplifier, also known as inverting op-amp, is a type of operational amplifier circuit which produces an output which out of phase with respect to its input by 180 degree, means there will be a phase shift of 180 degrees. This means if input pulse is positive, then the output pulse will be negative. Here we use two external resistors. One is RF, which is feedback resistance resistor, and R1 is input resistor. Applications of inverting amplifier. An inverting amplifier can be used as a trans resistance amplifier, which is also called as trans impedance amplifier. This amplifier works as a current to voltage converter used in less power based applications. Inverting amplifier is used at the output stage when any system is designed with different types of sensors. This op-amp maintains the equal potential of voltage at two terminals, so it can be used in many fields. These op-amps are all used in the mixers concept where the RF signals are present. RF represents feedback resistor. It can be utilized as a phase shifter. These type of op-amps are used where the balancing of signal is necessary. It is used practically in integration applications. The op-amp based inverting circuits are more stable. Op-amps are used in every electronic device where the linear integrated circuits are used. These are used in analog filtering and signal processing. These are used in various fields like communication, process control, displays, computers, measuring system, power sources, and signal sources. These are applicable in linear op-amp applications. Why is the inverting amplifier used? Inverting amplifier is used mostly for high frequency based applications where high input impedance is not used, because inverting op-amps are slew rate is high as compared to non-inverting type configuration. There is a formula for the inverting amplifier. The formula for the inverting amplifier is AV is equal to minus RF by RI. As I said, RF is the resistor feedback and RI is the input resistance, and negative sign represents the phase shift. Inverting op-amp waveforms. The inverting op-amp's input or output waveforms are shown here, and from the following waveforms it is very clear that the output is double in magnitude as compared to the input, and there is a reverse or phase shift in both input and output. This will be practically explained by my friend Padma. Advantages of inverting amplifier. These are not expensive. Its size is small. Versatility, dependability, flexibility. The device with inverting amplifier includes strong anti-interference capacity. It uses negative feedback. The gain factor is extremely high. Disadvantages of inverting amplifier. This has a small input impedance equal to R1. It has high gain, but the feedback must be maintained distortionless. The input signal should not include the noise because a small value will be multiplied and attained at the output, the signal is reversed. Thank you. Next will be continued by my friend Padma.
A simulation of inverting amplifier. Inverting amplifier consists of two resistor, three voltage sources, and one op-amp. And V1 is the input voltage, R1 is the input resistance, R2 is the feedback. Where you can find the R1, this is R2, and this is the op-amp, in which one of the terminal of the op-amp is grounded, and this V plus VCC and minus VCC are the same are the terminals of the op-amp, which is the same here. And now we'll be moving to the terminals which are grounded. V1, one of the terminal of the V1 is grounded. Inverting terminal of the op-amp is grounded, and one of the terminals of plus VCC and minus VCC are grounded. The input given to the circuit as follows: V1 has 1 kilo one voltage, R1 has the 1 kilo resistance, R2 has the 2 kilo resistance. And now the V1 which is given is in the form of AC, will be explained later. And now the plus VCC and minus VCC has the voltage of plus 12 and minus 12 volts, and these are the input given to the supply. The AC supply given to the V1 as follows. Click on the V1 and you'll get the advanced option in the desktop, and where you find the sinusoidal wave with the with the offset 0, amplitude 1, and the frequency 5. These are the input given as a AC in V1. And now coming back to these are the input given to the circuit. Now the output. Now output as follows. Here the output of the op-amp is just fed back to the input terminal. That is as follows. The simulation button, where you can find the edit simulation command. There the stop time has the 1 second, and the time to start the saving data has to be 0 second, and the main maximum time step required is 0.01 second. We can even we can minimize the maximum time step, because to get the correct sinusoidal wave, smaller the number of this, we'll get the better output. And now we'll run, the black screen will be popped up on the desktop. Click on the V1. Yeah, this is the input wave that we have given with the 0 second to 1 second, and with the amplitude of 1 volts. Click on the output terminal. This is the output from the inverting amplifier, which has the amplitude of 2 volts with a 5 frequency. Click on one of the waveform. You'll get the add plot playing command. Thank you.